amplifier,
Now here is the simple electrical diagram of an amplifier. Okay. So on the left hand side is the input. Okay. On the right hand side there is an output. Okay. Let me do an example of it. Now, say if I draw an amplifier in the middle. Okay. Then on the left hand side, on the input side, I have a microphone connect to the amplifier. So when I talk, the microphone produces a signal. Okay. Then on the other side of the amplifier, I have a speaker. So when the signal travels through the amplifier, the smaller signal gets amplified, magnified to a bigger signal. The important thing of this is the amplifier only amplifies the amplitude of the AC signal. Okay. Now, it does say it only amplifies the amplitude. So if you have a look at the AC signal, we talked about it before. It has a period, it has amplitude. The amplifier only increase, okay, changes the amplitude, okay, and the period remains unchanged. It means the frequency of the sound remains unchanged. So please always remember that. Now let's look at the gain of the amplifier. So we know that the amplifies the signal, it magnifies, it makes it bigger. Okay, and in order to measure it, when the designer design an amplifier, each amplifier has a gain. Okay. If the gain of the certain amplifier is say 10, okay, it means the signal has been magnified 10 times. So if the gain is say 20, okay, then the signal voltage, okay, the amplitude of the signal will be magnified 20 times bigger. Okay. And in reality, that's what's happening in theory, but in reality, there's a problem. So if you go to an electronic shop or you go to anywhere, you get an amplifier. And the information, okay, they will tell you the gain of the amplifier, and also they will tell you what we call it a range, okay, an input range of the amplifier. So let me give you an example. Okay. For a particular amplifier, say if the gain is 5, okay, and the input range is from -1 volt to say 1 watt. Okay. So what does it mean is, okay, the amplifier only have a gain of 5 between the input range of 1 volt to -1 volt to +1 volt. Ideally, we would like to make amplifier that have a gain of 5 for all the voltage, but practically it is not possible. So what they do is, for each amplifier, they have a range. Say the engineers, when they choose an amplifier, they need to work out the input range of the signal, then they choose the correct amplifier with the correct gain and a suitable range. Okay. For instance, for this amplifier, for this amplifier. So if I draw a table, okay, so when I have 0 volt input, okay, the gain is 5, is within the range, the output will be 0 volt. Okay, let me change the color. Now, however, if the input is minus 1 volt, okay, the output will be minus 5 volt. If the input is 1 volt, the output will be 5 volt. It all making sense with a gain of 5. Okay. The output is whatever the input times 5. Now, here is the tricky part, okay? Because in reality we cannot make an amplifier that has a gain of 5 for all the input. It's just not possible. So for this particular input amplifier, if I make an input of say minus 10 volt, okay, the output will be just minus 10 volt. Because the output will be minus 5 volt. Okay, because when the people who design this amplifier, it can only design this way. Okay. So within the range from minus 1 to 1 volt, within a certain range, the gain is 5. However, outside of it, there may be no gains. Okay. Just the gain of 5 the rule doesn't apply. Okay. Outside the range. For instance, say if I have 2 volt input, because the input range 2 volt is not in this input range, okay, the output of the amplifier may be just 5 volt. Okay, maybe something else, but most probably 5 volt. So if I have 10 volt input, let's start with 3 volt. 3 volt, the output will be 5 volt. Okay, if I have 10 volt, the output will be 5 volt. Because this rule only works within this range. Okay, now because of the unique property of the amplifier, okay, also the engineers or the scientists, they like to draw a graph. Okay, for that amplifier which has a gain of 5 and input range from minus 1 volt to 1 volt, I can draw this graph. Okay, the horizontal axis is the input, the vertical axis is the output. Okay, so you can say between minus 1 volt, okay, between the domain of minus 1 volt and 1 volt, okay, as an input, we have a linear line, okay, and the gradient in this case, the gradient is 5. So if I input 1 volt, the output should be 5 volts. The gain is 5. If the input is say 0.5 volt, okay, if I draw it on the graph, it should be 2.5 volt. Again, the gain is 5. Okay, but it only applies between minus 1 volt to 1 volt. Okay, if it's greater than 1 volt, no matter how greater is the input, okay, the output is only 5 volt. It cannot be any bigger. Okay. Similarly, if the input is less than minus 1 volt, the output is going to be minus 5 volt. Okay. It cannot be bigger, cannot be anything else. Okay. So the gain only apply within the range. Now, your task in year 12 is actually to be able to read this diagram. Okay? So the idea is that if I give you this diagram, if I give you this graph, you need to be able to tell me the gain. You need to be able to find out the gain from the graph and the input range from the graph. Okay, and able to tell me what's the tell me the output if I give you an input. For instance, if I ask you the output if the input is 0.01 watt. Okay, now you'll be able to tell me the output must be 0.5 watt because the gain is 5 and it's within the range. Now, just to make a note, okay, just I need to tell you the important thing is the gain is the gradient. Okay. The gain basically is the gradient of the graph. Now let's have a look at a question. Okay. This is a past year exam question. Okay. Exam in year 12 final year, sorry, a question in the year 12 final year exam. So okay, take a few minutes to read the question. Okay. We have an amplifier here. Okay. Here is the property of the amplifier. And then we have an AC signal. A standard wave signal travels through the amplifier. The question asks me, what's the output? What is the output signal looks like? Now, in order to do this question, let's analyze the property of the signal, the property of the um, amplifier first. Okay, so let's have a look. Now, step 1, let's have a look at the gain. What's the gain? Now, the gain will be the gradient of this graph. Okay, so if I read it just in this case, remember, be careful with the unit. Okay, the input is going to be 10 million watt, and the output is 4. So if I try to find the gradient of this graph, the rise over run, so it's the gain, okay, is going to be 4 watt divided by 10 million watts, so that's 0.01. If you do that, it's going to be 400. It is a very powerful amplifier. This time it amplifies the voltage by a factor of 400. Okay, now then let's look at the input range. Okay, so from this diagram, we see a flat line there. So the input range must be from minus 10 million volts to 10 million volts. So it's minus 10 million volts to 10 million volts. So let's put it properly. It will be 0.01 minus 0.01 volt to positive 0.01 volt. Okay. Then we have a input signal. Now, if I have a look at the input is a sine wave. Just remember, the period really doesn't matter because the amplifier only amplifies the amplitude. Okay, so we don't have to worry about the period. So, but if you have a look at the amplitude, it starts from a neutral point 0. Okay, then try to draw a diagram. Try to draw a table. So, input and output. Okay. So because we know the gain is 400, so when the input is 0 volt, the output must be the same. They must still be 0 volt. Okay. Because 0 times 400 is still 0. Then when the input is 5 million volts. The 5 million volts is within the range, so a gain of 400 still applies. Okay, so when it's 0.05 volt, If we read from graph, or you can just times 400, the answer will be 2 volt. Okay, the output will be 2 volt. Similarly, the minimum value is minus 5, so minus 0.05 volt. Then the output has to be 0 minus 2 volt. Okay, minus 5 minus 2, or minus 0.05 times 400. Okay, now, so the wave looks like this. Okay, so the output, okay, must also start from a neutral point 0, okay, and has a maximum of 2 volt, okay, and a minimum of minus 2 volt. Okay. The period doesn't change, the amplitude changes, so just it's still going to be a sine shape. So what we do is we just sketch it like this. Yep. So if you have a log, uh, so what's happening is the input in here, okay, with with amplitude of maximum 5 millivolt has been amplified, uh, or has been magnified 400 times bigger, becomes 2 volt. The shape still remains the same. Okay. Yep, this is what's happening. What you need to be able to do in the exam.